Today we're going to begin working with exponents, and in particular exponents with negative bases. Welcome to 50/50, everybody. We will also have our IXL lessons due this Sunday, so make sure you submit them to the correct place. If you're Mr. Baker's class, you are submitting to Monday, September 14th. Those are the 5 below that you need to do. So here we go. Apparently I've got lots of things. All right, so we are looking at exponents with negative bases. So we're going to talk about powers. We're going to talk about some vocab. You should have a packet, hopefully, that you can fill in. If you don't, you're going to kind of go through. Ooh, Mrs. Clark and Mrs. Kearns are going to love the noises. So factor. Okay, a factor is an integer that divides into another integer with a remainder of 0. So basically, if you have a factor, what that means is it goes into another number. Okay, using a power is a shorthand way of showing a product of equal factors or repeated multiplication. So it's a shortcut. Okay, exponents. Exponents tell you how many times a number or the base is used as a factor. Okay, the exponent is the small little number. Okay, we're going to talk about these in just a second with a visual for you. The power is when you have the base and the exponent together. So when you are looking at an expression, for example, if I give you something like this, that would be 2 to the third power. Okay, this right here would be our base, which we're going to get to. This would be our exponent, and together, this whole thing is called a power. So that's an expression with a base and an exponent is a power. Okay, squared is a fancy word for the second power. Okay, when you have a square, both sides, 2 sides are equal, so that'd be the same number times itself. So it's squared. We use that with area. And cubed is another unique one that's for the third power. So, for example, the example I wrote, 2 to the third power, can also be stated as 2 cubed because it's the same number times itself 3 times. All right, so as we look at these, this is what, excuse me there, this is what 2 to the 5th is a power. Okay, the small number 2, and you guys are going to be filling those in. This small number 2 is your base, and the little number is the exponent. The tiny one's the exponent. Now, it is not 2 times 5. The expanded form, we call this the expanded form, is 2 times 2 times 2 times 2 times 2. Remember, the little number tells you how many times to use the base as a factor. And so 2 times 2 is 4. This 2 times 2 is 4. And we still have another 2. And 2 times 2 is 16. Or 4 times 4 is 16 times 2 is 32. So 2 to the 5th power is 32. Now, why is there this glue bottle? What I want you to do, and this is going to help us with these negatives, is I want you to think of this super glue bottle. And whatever this exponent right here touches, it's super glued to. So that exponent is super glued to whatever it touches. And so in a moment, hopefully that will help you understand when it means negative, when it means the opposite of. So as we look at this, 2 to the 5th is a power. And we just kind of went through this. 2 is the base, 5 is the exponent, and it's 2 to the 5th is 2 times 2 times 2 times 2, which is 32, as we just talked about. So as you go through this, we're going to write this. We're going to just write using exponents. So when you have 7 times 7 times 7 times 7, a faster way to write that would be to write 7 as the base, and 4 is your exponent. If I had 2 times 2 times 2 times 2 times 2 times 2, easier way to write that would be 2 to the 6th power. And that's why we call it a shorthand. It's a shortcut. It's a faster way to write. Okay. And in this case, it says do not simplify. We just want to write what they are. Now, as we get into these, so this one, and I like to write it in expanded form. This is not 16. This would be 8 times 8. So this one is equal to 64. This is 1 times 1 times 1 times 1. So it's not 4, but it is just 1. Now, we're going to talk about the powers of 10, and I'm actually going to I'm going to go over here and do those in a different color real quick. And we're going to go, let's just start with 10 to the 3rd power. And what that means is 10 times 10 times 10. And that means I'm going to have a 1 with 3 zeros. Now, powers of 10 are really nice because the exponent, so if I go to 10 to the 2nd power, that means 10 times 2. That would mean I'd have a 1 with 2 zeros. 10 to the 1st, I'd have a 1 with 1 0. If I had 10 to the 4th, this is 10 times 10 times 10 times 10, and it's going to be a 1 with 4 zeros. So next year in 8th grade, when you guys talk about scientific notation, that's why we use it, or in science class they might mention it, because powers of 10 are nice and easy, and so really all that happens is decimal points get moved, and you can see the nice thing is the exponent with a power of 10, hint, hint. So when you guys do your homework on Monday, there's an example that's like 10 to the 7th power. Well, that's super easy to do. You just put a 1 with 7 zeros. This is the number of zeros. Now, this only works with powers of 10. Okay, now 2 to the 3rd is 2 times 2 times 2, which is going to give you 4 times 2, which is 8. And it's not a bad idea for you to show it. Now, this is the one that throws everybody off, and that's why I ended up doing these powers of 10 here. If you notice the pattern, we asked for 10 to the 0 power. Well, 10 to the 0 power is not going to be 0, okay? That's what the common misconception is. This is well, so now based on what I just said here, this is going to be a 1 with no zeros behind it. And so this is actually just any number. This is just kind of something you want to memorize. It's always one of the most missed. Any number to the 0 power is always equal to 1. So if I were you, I would star that. It tends to be one of the most missed questions, kind of like one of these questions. I also get this as most missed. If I give you a division question like this is not equal to 0. It is, whoops, I can't really spell, undefined, okay, whenever you're dividing by 0. So any number to the 0 power is equal to 1. So if I had 18 to the 0, or if I had, whoops, that was supposed to be an 18 to the 0 power, that would also be 1. If I had 21 to the 0 power, it is equal to 1. Any number to the 0 power is always equal to 1. So those are our basic exponents. Now, notice we have no negatives, okay? Next year, you'll talk about negative exponents, and that does something, but we're not going to get into that next, or just yet. Now, these two, oh, man, I'm missing the negatives. That's not very helpful. So there's a negative here, and then there's a negative here. So for some reason, it didn't carry over into this PowerPoint, but iPads versus computer. All right, now, so this one's a little bit tricky, and what the problem is, are they saying the same thing? And obviously, if I'm going to spend this much time talking about it, they're not going to be saying the same thing. So in this first example, we got to think about our super glue bottle. I think things pop up for me on this example. So here's our super glue bottle. So notice, in this first example, the exponent is super glued to these parentheses. And so when it's super glued to the parenthesis, you have to be thinking about what's inside the parentheses. And so inside that parenthesis is a negative number. So that one truly is saying, okay, it is truly saying, and you want to write this down because this is going to be a big one. Mrs. Stroll, one of the 8th grade teachers, always gives me a hard time about my students not saying some of these correctly. But this one truly means negative 4 squared. So that means, now once again, the negatives are missing. Gotta love it. So it's really saying negative 4 times negative 4. Now, why is that important? Because the rule is same sign positive. Well, same sign positive, that makes this answer positive 16. Now, this next example, there are no parentheses. And so the 2 is only super glued to the base. And since it's only super glued to the base, it isn't really saying negative. We have to use this word opposite. And so what it's really saying is the opposite of 4 to the 2nd power. And so when we write that, it's written this way, and I need to, bear with me folks, for some reason, the symbols are not all appearing. So this is going to be a negative, and there should be a dot here. Okay, and so what happens is you got to do what's inside the parentheses first, and 4 times 4 is 16, and now the opposite of 16 is negative 16. So as we do that one, you can see the difference. I'm going to erase this so you can see. When you have parentheses, it's around the negative. It's super glued to the parentheses, and therefore it's a negative times a negative, which makes it a positive. If there aren't parentheses, it's now the opposite of, and the answer ended up being negative. So there is a significant difference. So now we're going to go through and do a couple more examples real quick. And once again, you got to love my lack of negatives. All right, so here we go. On this first example, we have this exponent, and I'm going to change colors, is super glued only to the 7. So it's really saying not negative 7 squared, but the opposite of 7 squared. Well, 7 times 7 is 49, and the opposite of that is negative 49. So example 1 would be a negative, Example 2 is super glued to the parentheses, and inside the parentheses is a negative number, so this one is really saying -7. So this one is saying the opposite of, and this one is saying -7, okay? And so negative times a negative makes it a positive, so you'll notice that makes it a positive answer. Now, this next example, it's super glued to the parentheses, so it's truly saying -5 times -5 times -5. Now, what we have to be cautious of, we're going to do one step at a time. Well, these two signs are the same, which gives me positive 25. And this is -5. Now, this is a positive times a negative. Signs are different. My answer is negative. And if I had 5 quarters in my pocket, that'd be $1.25. So if I were to multiply these, it's 125. Now, we're going to go on, and then I'm going to talk about this one again in just a moment. So this one now is super glued just to the 5, the base. So up on number 3, it was super glued to the parentheses, so it really was saying -5. This one is saying the opposite of 5, okay, to the third power. Now, that means I'm going to keep that negative outside the parentheses, and I'm going to go 5 times 5 is 25, times 5 is 125, and the opposite of that is negative. So now, this is tricky. Well, on the first 2 examples I just showed you, one of the answers ended up being positive, one of them ends up being negative. On this example, they both ended up being negative. Now, there is a reason for that, and you're going to want to add this. When the exponent is odd, okay, there's always going to be this extra negative. So notice, these two paired up and became positive, but then there was a 1 extra negative. So when the exponent is odd, the answer is going to be negative, no matter what. Okay, if the exponent is even, then they're going to have a pair to do the same sign, which makes it positive. So if the exponent's even, it's going to be positive. Okay, now that's only if there's parentheses. If there's not parentheses, it's the opposite, and that's always going to be negative then. And if the exponent is odd, then it really doesn't matter if there's parentheses or not. The answer will be negative in those cases. All right, so I know that it was a short version. You guys are going to do an Exponents with Negative Bases worksheet. Okay, you're going to either download it. You guys can upload it. You can actually show your work on it and upload that. You could write all your work on paper. I don't care. You can print it, but you guys are going to upload your work. So you can take a picture of it or upload it. So you guys, this one's a perfect one for you guys to actually write on it. And then don't forget, you have IXL lessons. I would strongly recommend you get them done early on, and then this is always, for me personally, a great way. So when you guys see the 81 here, and I see some of you getting 100, and you have, this is a great one. When you guys have this results, just take a picture of that and upload it. All right, I hope you guys had a great first couple days of 50-50, and that's it for Exponents.